Hello everyone, welcome to this session. Today we are discussing regarding the stream gauging, which is a part of the unit 3, and this is also called as stream flow calculation. Now before proceeding further, let's have the glance on content of unit 3. In that we are going to study stream gauging, selection of site, discharge measurement by area velocity method, slope area method, floods, estimation of peak flow, empirical equations, rational method, importance of design flood, standard project flood, maximum probable flood, introduction to flood frequency analysis. Stream gauging or stream flow measurement. Stream flow representing the runoff phase of the hydrologic cycle is the most important basic data for hydrologic studies. It was seen in the previous chapters that precipitation, evaporation and evapotranspiration are are all difficult to measure exactly, and the presently adopted methods have severe limitations. In contrast, the measurement of stream flow is amenable to fairly accurate assessment. Interestingly, stream flow is the only part of the hydrological cycle that can be measured accurately. A stream can be defined as a flow channel into which the surface runoff from a specified basin drains. Generally, there is considerable exchange of water between a stream and underground water. Stream flow is measured in units of discharge meter cube per second occurring at a specified time and constitutes historical data. The measurement of discharge in a stream forms an important branch of hydrometry and the science and the practice of water management. So, friends, if you see, so stream gauging or stream flow measurement is the most reliable method where you can find the data is measured or the flow is measured accurately. Stream flow measurement techniques can be broadly classified into two categories as direct determination and indirect determination. Under each category there are host of methods. The important ones are discussed below. Direct determination of stream discharge, in that area velocity methods. So we are going to study this. Dilution techniques, electromagnetic method and ultrasonic method. Then in indirect determination of stream flow, hydraulic structures such as weirs, flumes, gated structures, and second is the slope area method that we are going to study in detail. Measurement of stage. A stage of river is defined as its water surface elevation measured above a datum. This datum can be the mean sea level (MSL) of any arbitrary datum connected independently to the MSL. Now let's discuss on the manual gauges first. In that first one, staff gauge. The simplest of stage measurements are made by noting the elevation of the water surface in contact with the fixed graduated staff. The staff is made of durable material with a low coefficient of expansion with respect to both temperature and moisture. It is fixed rigidly to a structure such as an abutment, pier, wall, etc. The staff may be vertical and inclined with clearly and accurately graduated permanent markings. The markings are distinctive, easy to read from a distance, and are similar to those on a surveying staff. Sometimes it may not be possible to read the entire range of water surface elevations of a stream by single gauge, and in such cases the gauge is built in sections at different locations. Such gauges are called sectional gauges, which is shown in the figure. When installing sectional gauges, care must be taken to provide an overlap between the various gauges and to refer all the sections to same common datum, which is shown in the figure. Now you can see in the this staff gauges, the first figure has been shown here as a, these are the vertical staff gauge. So you can see a vertical staff gauge has been provided here, and it is nothing but it is associated with the abutment of the that particular water structure. And sometimes a sectional staff gauges may be provided. You can see these are the provided at the locations. Then let us discuss regarding the wire gauge. It is a gauge used to measure the water surface elevations from above the surface of such as from a bridge or similar structure. In this, a weight is lowered by a reel to touch the water surface. A mechanical counter measures the rotation of the wheel, which is proportional to the length of wire paid out. The operating range of this kind of gauge is about 25 meter. Then let us discuss regarding now automatic stage recorders. The stop gauge and wire gauge described earlier are manual gauges. While they are simple and inexpensive, they have to be read at frequent intervals to define the variation of stage with time accurately. Automatic stage recorders overcome this basic objection of manual stop gauges and find considerable use in stream flow measurement practice. Two typical automatic stage recorders are described below. The first one, float gauge recorder. A float operated stage recorder is the most common type of automatic stage recorder in use. In this, a boat operating in a steering wheel is balanced by means of a counterweight over the pulley of a recorder. Displacement of the float due to rising or lowering of the water surface elevation causes an angular displacement of the pulley and hence of the input shaft of the recorder. Mechanical linkages convert this angular displacement to a linear displacement of a pen to record over a drum driven by clockwork. To protect the float from the debris and to reduce the water surface waves effect on the recording, steering wheels are provided in all float type stage recorder installation. Now in the figure you can see here, this is the recorder, and the manhole is shown here, and the counterweights you can observe, and this is the float. Okay, then to approach this, if walkway is there, and in the intake this top gauge is also provided here. So figure shows a typical steering wheel installation. Note the intake pipes that communicate with the river and flushing arrangements to flush these intake pipes of the sediment and debris occasionally. The water stage recorded has to be located above the highest water level expected in the stream to prevent it from getting inundated during floods. Further, the instrument must be properly housed in a suitable enclosure to protect it from the weather elements and vandalism. So we'll have to take care here that it should not be clogged with the various debris and other material. So we'll have to take care for its proper location. So this is a typical section of a stilling well installation where we'll have to keep watch on this two major when you are recorder type of manhole, we'll have to keep watch on the counterweight and the float. On account of this, the water stage recorder installations prove to be costly in most instances. A water depth recorder is shown in the figure. So this water depth recorder is shown in the figure. You can observe the parts which we have discussed regarding the float and the counterweight. Okay, so water depth recorder. This is a Stevens type F recorder. So you can see here the counterweight and the float. Okay, and this is the counting mechanism is there. Then let's discuss regarding the bubble gauge. In this gauge, compressed air or gas is made to bleed out at a very small rate through an outlet placed at bottom of the river. A pressure gauge measures the gas pressure which is which in turn is equal to the water column above the outlet. A small change in the water surface elevation is felt as a change in pressure from the present value at the pressure gauge, and this is in turn adjusted by servo mechanism to bring the gas to bleed at the original rate under the new head. The pressure gauge reads a new water depth which is transmitted to a recorder. The bubble gauge has a certain specific advantages over float operated water stage recorder, and this can be listed as under. There is no feed for costly stilling wells. A large change in the stage as much as 30 meter can be measured. The recorder assembly can be quite far away from the sensing point, and due to constant bleeding action there is a less likelihood of the inlet getting blocked or choked. So you can see here, this is the instrument room is there, and actually the pressure point is provided here, the bubble gauge. Okay, so this is a more convenient method. So the more elaboration of this particular system has been shown here, the parts 1, 2, 3, 4 and 5. Now in that this part first is a high pressure bottle is there. Okay, then second gas adjustment unit. Okay, then third pressure to the point, fourth is a mercury manometer, and fifth is a recorder. So all this bubble arrangement, so it is very easy and convenient method to take the measurements. So friends, today we have discussed regarding the river gauging, in that manual gauging and also the automatic gaugings methods we have studied. So in coming sections, we are going to study the the various methods which are associated in our curriculum, to study those methods with the proper examples and animations. So stay tuned and attend all the sections. Thank you very much.